A train station stands at an incredible 3,454 meters above sea level, making it Europe's highest railway station. But this isn't just about height, it is about building deep within the solid rock of Eiger and Mönch mountains. An astonishing 80% of its 9.3-kilometer railway line runs through tunnels carved into the heart of these peaks. The newest way to access this marvel is the Eiger Express, a cable car spanning 6,483 meters, transporting 2,200 people every hour in just 15 minutes. This system uses a special tri-cable design, needing only 7 support towers across its entire 6.48-kilometer length. This is part of a massive ongoing project in the Swiss Alps that also includes laying 9,600 meters of new track and installing 8,000 sturdy oak sleepers for other vital mountain railways. The question arises, how are engineers able to build and maintain such complex systems in the heart of the Alps, battling extreme weather and solid rock? The story of reaching the Jungfraujoch began over a century ago with a bold vision. In 1893, a Swiss entrepreneur named Adolf Geyer-Zeller was hiking and observed a train on a mountain railway. A sudden idea sparked to build a railway to the Jungfrau Peak itself. This plan was unique because it proposed starting from Kleinscheidegg, a station already situated high up at 2,064 meters above sea level, and then tunneling directly into the mountains. This approach demonstrated a pioneering spirit, recognizing that the most direct and protected route lay within the mountain. Construction of this ambitious project began in 1896. Workers faced immense challenges, having to blast their way through solid rock using the early engineering methods available at the time. It took 16 long years to complete the 9.3-kilometer line. A remarkable 7 kilometers of this railway runs inside deep tunnels, a testament to the scale of the excavation required. The Jungfrau Railway finally opened in 1912, reaching Jungfraujoch at 3,454 meters. It quickly became recognized as Europe's highest railway station, a monumental pioneering feat and a lasting symbol of Swiss engineering skill. This enduring spirit of innovation and determination to conquer challenging alpine geology continues today with the V-Bahn project, a modern update to this historic route, designed to make access to the top of Europe even faster and more comfortable. The V-Bahn project represents a significant leap in alpine infrastructure, building upon a century of experience. This massive undertaking, costing approximately 470 million Swiss francs, is designed to enhance connectivity and visitor experience in the Jungfrau region. At the heart of the V-Bahn project is the Eiger Express, a modern tri-cable gondola that began public operation in December 2020. This innovative system travels a distance of 6,483 meters from the Grindelwald's terminal to the Eiger Gletscher station, dramatically cutting the journey time to just 15 minutes. This efficiency translates into a substantial 47-minute saving on the overall trip to Jungfraujoch, allowing visitors more time to enjoy the high alpine environment. The 3S system is fundamental to the Eiger Express's design. This technology employs 2 strong track ropes, which allows for very long distances between support towers. As a result, only 7 towers are needed across the entire 6.48-kilometer route. This design choice is not merely about engineering efficiency, it also plays a crucial role in protecting the natural mountain environment by minimizing the visual and physical footprint on the landscape. This system is also exceptionally stable, even in strong winds, ensuring reliable operation in challenging alpine weather conditions. Further demonstrating a meticulous approach to environmental integration, the system incorporates sound-optimized bull wheels and new hold-down sheaves to reduce noise emissions, which is particularly beneficial for installations requiring minimal environmental impact. Each of the 44 gondola cabins is designed for comfort and can carry up to 26 people. These cabins are equipped with heated seats, Wi-Fi connectivity, and expansive panoramic windows that stretch from the floor to the roof, offering breathtaking views of the Eiger North Face. For an even more exclusive experience, there is a special VIP cabin, numbered 888, which features a champagne bar. Behind passenger transport, a hidden marvel of the Eiger Express is its fully automated freight transport system. This system can carry up to 2 tons of goods, such as food and supplies, directly into the mountain station. It operates seamlessly alongside passenger service and includes a 40-meter tunnel that connects it to the Jungfrau Railway, showcasing remarkable logistical integration for supplying the high-altitude facilities. Transporting the massive steel ropes for the Eiger Express was an engineering feat in itself, presenting unprecedented logistical challenges for a Swiss aerial ropeway. Each of the 4 main ropes was an impressive 6,940 meters long and weighed 132 tons. Moving these colossal components required specialized convoys of 3 trucks, each measuring 65 meters in length and weighing a combined 212 tons, powered by 1,580 horsepower engines. These convoys had to navigate narrow, winding mountain roads and cross bridges that were originally designed for much less weight. In some instances, the ropes had to be temporarily unwound across bridges to distribute the load and ensure safe passage. The installation of each individual rope was a complex and time-consuming process, taking between 9 and 13 days. It required the use of approximately 400 tons of specialized tools and the installation of 188,000 meters of auxiliary ropes and cables. Once visitors arrive at Eiger Station, located at an elevation of 2,320 meters above sea level, they transfer to the historic Jungfrau Railway. This station serves as the last open-air stop before the train enters the mountain's core for the final ascent. The Jungfrau Railway is a rack railway, a specialized type of train designed for steep inclines. It uses a special toothed gear on the train that locks into a toothed rail laid between the main tracks. This mechanism allows it to climb incredibly steep slopes, reaching a maximum gradient of 25%. To put this in perspective, a 25% gradient is like climbing 1 meter vertically for every 4 meters traveled horizontally, akin to ascending a very steep hill. This robust technology is crucial for navigating the extreme topography of the Alps. The Jungfrau Railway is also unique because it operates using a 3-phase electric power system. Trains collect power from 2 overhead wires, with the 3rd phase earthed to the track. Modern trains on this line are equipped with regenerative braking, a system that allows them to generate electricity when going downhill. This recovered energy, approximately 50% of the energy used for the climb, is fed back into the power distribution system, contributing to the railway's overall efficiency and sustainability. The majority of the 9.3-kilometer line, specifically about 7 kilometers, runs through tunnels carved deep into the formidable Eiger and Mönch mountains. Along this subterranean journey, there are stations built directly inside the rock. Eiger Station, now closed, was notable for its windows carved into the mountain face, offering passengers a glimpse at the outside world from inside the Eiger. The Eismeer Station, located at 3,158 meters, still allows visitors to step out and observe a glacier through a viewing window, providing a unique interaction between human construction and natural geology. The final destination is Jungfraujoch, Europe's highest railway station at 3,454 meters. This entire complex is underground, a network of tunnels connecting to various viewing platforms and ice palaces. These stations are not merely transit points, but engineered viewing platforms, demonstrating that the purpose of such deep tunneling extends beyond just transport to creating unique human experiences. Building these tunnels over a century ago was an incredibly tough undertaking. Engineers primarily used the drill and blast method, a technique still effective today for excavating through solid rock. This process involves drilling precise holes into the hard rock, carefully placing explosives inside, and then detonating them in a controlled manner to fracture the rock into manageable pieces. While this method remains a staple in tunneling, its execution with the technology of the early 1900s was far more laborious and dangerous. The rock excavated from these tunnels was not simply discarded. It was ingeniously used to create concrete for the tunnel linings, showcasing an early form of resourcefulness and circular economy in construction. The reliance on drill and blast for over a century, especially in the varied and challenging rock types encountered in Swiss tunnels, demonstrates that fundamental, robust engineering methods, perfected with precision, remain essential for conquering such demanding geological conditions. Beyond the grand projects like the Jungfraujoch, Switzerland is also committed to upgrading other vital mountain connections. The Mürren Mountain Railway, known as BLM, serves as a key link to the picturesque and car-free village of Mürren. This railway recently completed a significant 4-year renovation project, costing 63 million Swiss francs, with work concluding in November 2023. A core part of this project involved the complete replacement of the track infrastructure. Workers laid 9,600 meters of new track, a distance comparable to almost 10 kilometers. They also installed 8,000 new oak sleepers, which are the sturdy wooden or concrete blocks that support the rails. This extensive work required moving several thousand tons of ballast, the crushed stone that forms the railway bed. The renovation also focused heavily on making the railway more accessible for everyone, aligning with modern standards for inclusive design. This included building barrier-free toilet facilities at Grootschaap Station, adding a lift to the renovated Mürren station, and upgrading Winteregg Station with new lifts and a passenger subway. The Grootschaap Workshop, a crucial maintenance facility, was also modernized. New, modern trains from Stadler were delivered to increase capacity and comfort for passengers. These trains feature spacious panoramic windows and comfortable seats, along with updated passenger information systems. They can now reach speeds of up to 50 kilometers per hour, a significant increase from the old 30 kilometers per hour, effectively cutting down travel times and enhancing the appeal of the car-free village of Mürren. Delivering these new trains to the BLM line presented a major logistical challenge because the line is not connected to the main national rail network. To overcome this, parts of the new trains had to be transported on special radio-controlled road vehicles, carefully navigating the winding mountain roads. Testing the trains in the harsh, high-altitude, snowy conditions at 1,600 meters above sea level, often at night, was also extremely difficult and time-consuming. These ambitious projects represent a significant and strategic investment in Switzerland's future, demonstrating a holistic approach to infrastructure development. The V-Bahn project, which includes the Eiger Express, cost approximately 470 million Swiss francs. The comprehensive renovation of the Mürren Railway added another 63 million Swiss francs, bringing the combined investment to over 530 million Swiss francs. This substantial financial commitment is yielding considerable returns. The Eiger Express alone cuts travel time to Jungfraujoch by 47 minutes, making it significantly easier and faster for people to reach the top of Europe. The upgrades to the Mürren Railway enhance connectivity to places like Mürren, a beautiful car-free village, thereby promoting sustainable tourism by encouraging train travel over private cars and reducing environmental impact. These projects also actively contribute to preserving the unique alpine environment by incorporating designs that minimize ecological footprint, such as the Eiger Express's minimal number of support towers and its integrated, automated freight system that reduces road traffic for supplies. We encourage you to like this video, subscribe to the channel for more in-depth dives into engineering wonders, and turn on notifications so you don't miss new adventures.